Okay, we are ready for section 1.5. In this video, we're probably going to get through this first page. We are going to continue talking about linear equations and functions, and we are going to talk about how you find the zero of a function. So let's start by just a little review. Equivalent equations, we talked about that already. Those are equations that have the same solution. And you can get equivalent equations by doing things like adding something to both sides, subtracting a number from both sides, multiplying or dividing. As long as you're doing the same thing on both sides, you can do all four of those operations. And your goal here to solve an equation is to find is to get to the point where the variable is isolated. And what that means is you end up with x equals, so x is by itself on one side and all the numbers are on the other side. So that is the process that we're going to do to solve some equations. We're going to just keep rewriting those as equivalent equations by using the addition, which also includes subtraction principle, adding or subtracting something to both sides. The multiplication principle, which says you multiply or divide both sides by a number, and until we get to the point where we have x equals. So this hopefully is some practice, hopefully review. If you need more practice, definitely look into more of these from section 1.5 until you get really comfortable. This is very important as we go on this semester, that you can do problems like these that you see on the screen right now. Okay, so this very first one, there is our x. I usually start by finding my x, and then I say, okay, what do I need to do to get x by itself? So in this problem, on the side with the x, we have a 4 and we have a 2. The 2 is being multiplied by x. The 4 is 4 minus, and then this unit, the 2 and x. So you can do the division by 2 first, or you can subtract by 4 first. I will tell you it's much, much less messy if you do minus 4 first. Get that 4 off of the side with the x. If you divide by 2, you just need to make sure that you divide everything by 2. So you're going to divide the 4 by 2, the 2x by 2, and the 11. So definitely our best bet here is to subtract 4, and that's I would say that's pretty much the rule you want to follow, even though, in all honesty, you could do the division first. So keeping my negative sign in front of my 2x, I have negative 2x because the 4's canceled out. And then on the right-hand side, I have 11 minus 4, which gives me 7. So now I will divide by the negative 2. Again, we are working toward getting x by itself, so I'm dividing by the coefficient or the number that's in front of the x. So those cancel out, and I'm left with just x on the left. And on the right-hand side, I have what I believe is my solution, 7 divided by negative 2, which is a negative 7 over 2. Now, I would suggest you get in the habit right now of always checking your answer. I'm going to erase that line so I can see the original problem a little bit easier. Always check your answer, and the way you do that is checking to make sure it's a solution. And our definition of solution from a few lessons ago was that it is it makes it true. So if we replace the x with negative 7/2, and this is true, then we know that we have the correct solution. So I'm just going to rewrite the original problem, but I'm going to replace the x with negative 7/2. Remember, this is 2 times x, so this is 2 times negative 7 over 2. So this is a multiplication, equals 11. And now I can work that through. If I'm taking 2 times a negative, that's going to give me a negative, but I'm also subtracting a negative. So I'm going to just get rid of those negative signs right off the bat just to make it a little easier. And now over here on the left side, order of operations says that I do the multiplication first. And to multiply times a fraction, I'm just going to put the 2 over 1. The 2's cancel, and I'm left with 7 over 1, or just 7. So 4 plus 7 equals 11. And I know that that's true. Once you get to something that you know is true, your check is done. And the solution that you found is correct. So I only did that until I determined that it was correct. I overlapped a little bit here. There we go. Okay, so let's look at the next one. The next one is similar, except it has fractions. So we could go through the exact same steps that we did before. We can subtract the 3 and then divide by 6/5. But notice when we subtract the 3 from 3/5, that's going to get a little messy. Dividing by 6/5 is kind of messy, but you can certainly do that. But a trick that you might want to learn is to always find the least common denominator, which is the smallest number that both of your denominators divide into evenly. In other words, the least common denominator is the smallest number that can be divided by 5 and 10 evenly. So if you think about numbers that you can divide 5 into evenly, would be 5, 10, 15, 20. 10 goes into 10, 20, 30, 40. So what was the smallest number that was in both of those sets? 10. So if you multiply both sides of the equation times 10, you're going to be able to get rid of the fractions, and then the problem is going to be a lot easier to tackle. So I'm going to pause the video. You can pause as well, or you can pause it after I write this down. I'm going to pause as I rewrite the problem being multiplied by 10. Okay, so if that worked correctly, this should have just appeared right here, this next expression or this next equation. I've basically taken my original equation and I've just multiplied every term by 10. So over here on the left, I had to distribute the 10 so that it is taken times, oops, I have a typo there. This should be a 3, not an x. So I have 10 times the 6/5 x plus 10 times 3 equals 10 times 3/10. And so when I worked through this, putting the 10 over 1 and working through this first multiplication, my 5 and my 10 reduce to a 2 over 1. So I end up with just 6 times 2, or 12 times x. 10 times 3 we know is 30, equals, and then over here on the right, again, putting my 10 over a 1, and then the 10s cancel. I get 3 over 1, or just 3. So see how that really simplified and made this problem much closer to the first one. We now don't have any fractions. We're just going to subtract the constant, which is 30, and then divide by 12. So I'm going to do those steps real quickly. And actually, I'm just going to skip ahead to the answer. So subtracting 30, I get negative 27. Divided by 12, I get negative 27 over 12. X equals, and 12 and 27 both divide by 3, so I get negative 9 over 4 as my solution. And just like before, I really recommend that you do a check. I'm going to pause and fill in the check right over here just to save the time as I write it with my mouse, and then we'll talk through the check. So do that on your own and then restart the video. Okay, so my check is that I take my original equation. Let me clean this up so we can read it again. 6/5 times x. So this was 6/5 times x. We found was negative 9/4 plus 3 equals 3/10. When I do this multiplication, I can reduce the 6 and the 4. So I get 3 over 2, and I end up with 3 times 9, 27 over 5 times 2, which is 10. And I'm done with my check because I know if I take negative 27 over 10 plus 3, 3 is the same as 30. Oops, I didn't mean to erase that. 30 over 10. So if I take 30 over 10 plus a negative 27, that gives me a positive 3 over 10. And I know that I'm done. So once you get to the point that you can see that it's a true statement, your check is done. And then go back and just put a box or circle your answer. So the answer here, the solution is x equals negative 9/4. Okay, let's move on to this next one. Okay, on this one I added this because we have some parentheses. So before we can do those steps that we've been doing, we want to simplify and get rid of parentheses. So I'm going to distribute the 2. 2 is being multiplied by this whole thing. So I have to take 2 times the x, and then 2 times the 4, and notice that I keep that negative, so it's minus 8. And then on the right side, I do the same thing with the negative 5. 5 times 2 is 10x. And remember, you're distributing the negative with the 5, so it's negative 5 times 1, which is negative 5, or subtracting 5. Now on this right side, I have two constants. So anytime on the same side of the equal sign, you either have two terms that have the x, you would combine those, or two terms that are constant, you want to go ahead and combine those before you move on. So over here on the right side, these are on the same side of the equation. So I just combine them. I don't, it's a 3 and a -5. Combining those, I get a -2. So this equation is 2x minus 8 equals -2, that's my 3 minus 5, minus 10x. Now I have x's on both sides, so I need to subtract the x's from one of the two sides and then move the constants to the other. So I'm going to add 10 to both sides so that all my x's are on the left. And then I'm going to move my constants to the other side, so I'm going to add 8 to move that to the right. Okay, I'm kind of running out of room. Hopefully you can see all that. 10x plus 2x is 12x. And my 8's cancel. I've moved it over here. -2 plus 8 is 6. To solve this, I'm going to divide by 12. And I get x equals 1/2. And let's do a quick check. I'm going to do this without writing, maybe. Let's see. Over here I'm going to have 1/2 minus 4, 1/2 minus 4. That would be 3.5. So 2 times 3.5 is 7. Okay, on the right side, again, I'm going to start in my parentheses, replacing the x with 1/2. I have 2 times 1/2 plus 1. Do the multiplication first. 2 times 1/2 is 1, plus 1 is 2. So this whole thing is 2. 5 times 2 is 10, so I have 3 minus 10 is -7. Let me see, did I lose? Yeah, I lost the negative over here. This was 1/2 minus 7, or minus 4. So that was a -3.5 times 2, which is -7. So I have -7 equals -7, which is true. I didn't write that whole check out because we're kind of running out of room here, and I'm trying to write with my mouse, but hopefully you were able to follow that. Definitely always recommend doing your check. Even if you don't write it out, make sure that you're checking it in your head. Okay, I'm going to erase a little bit here. I kind of covered up my problem a little bit. Let's do this last one. Again, I want to solve for x. Right now I have x's on both sides, so I need to subtract 10x to get them onto the same side. And then I want my constants on the same side. So I'm moving my variables to the left and my constants to the right, so I'm going to add 3 to both sides. But what happened is, on this left side, everything actually canceled out. So I get a 0 equals 8 plus 3, which is 11. Since I had 10x on both sides, when I went to subtract, I lost all of my x's. So whenever this happens, you need to think about what's left. What's left? Is it true or false? What I have left is 0 equals 11. Is that a true statement or a false statement? Well, we know it's false, right? So anytime you end up with a false statement when the variables disappear, the answer is no solution. Okay. Now, if this had happened and the variables had gone away, but you have a true statement, like maybe 0 equals 0 or 3 equals 3, then your answer would be all real numbers. And that will probably show up on some homework problems. So maybe make a note out here to the side that if that had been true, your answer would be all real numbers. Okay, one last thing we're going to cover in this video before we move forward is defining what the 0 of a function is. The 0 of a function is the value that makes it equal to 0. So in this problem, we're asked to find the zeros of f of x equals 5x plus 20. You're going to find that by setting it equal to 0 and then solving for x. So to solve this for x, we need to subtract 20 from both sides. We get 5x equals -20. And then divide by 5. And we get that our 0 is x equals -4. 4. Okay, we're going to stop there. We're going to do some calculator exercises, and then I'll be back with some application problems.